Good morning, Tom in California, and the other panelists around the world. Hello to the visitors on the screen, whenever and wherever you watch it. Welcome to the first eFlight Expo panel discussion at Aero 2020. As you know, the Aero 2020 has been, like many other events, cancelled due to the coronavirus. But over the last years, the panel discussions at the eFlight Expo at Aero has been a highlight of the show and packed with information and news from the electric world, from Volocopter over Siemens, Uber Elevate, and many others. We want to keep this tradition and inform you as possible online now about the latest news in electric aviation. The first panel, which we will have, is about the core of electric aviation, the propulsion system. So welcome with me our guests, which are Olaf Otto, Rolls-Royce Electrical, Tom Gunnarson, Wisk, Aero and ASTM, Konstantin Kondak, Elektra-uas, Uwe Kiesewetter from Airbus, CityAirbus, and me, it's Willi Tacke from eFlight Expo. Okay, good. Then I would ask perhaps Olaf, as we talk about motors, and Olaf is representing a manufacturer of electric motors for aviation. Give us a short update of what Rolls-Royce is doing and planning and where you are with the certification for electric motor systems.
Basically, we have an engine that is currently in the process of certification with EASA and then concurrent certification with the FAA. We started the activities to have the engine certified now in terms of starting the discussions and registering the type certificate last year. And we've made quite a bit of progress. We started to basically look at a certification under CS23, and the aim was to certify the engine under CS23 ELA1, so the simplest category of CS23, if you will. We've gone through a number of different iterations and discussions. We're currently now at a stage where the TC has been registered. We are actually running the certification under CSE, with the concurrent certification still in the US with the FAA. The means of compliance are in discussion, and we're hoping to finalize those by the summer, and then the process of certification can start, and however long that takes us in the end, we're quite hopeful to have that ready in the next few years. We're not doing that completely in kind of an empty space. We're working together with by Aerospace in this instance, because we're trying to align with them. They are currently using the engine, and they are also in the process of running a certification program for their aircraft, and they will use then the type certificated engine from our side as part of their overall aircraft TC. One interesting point, I think, is in terms of the scope of the type certificate. So the focus for the type certificate from our side is the electrical machine plus the inverter and controller, and that for us is kind of the smallest box that you can have as a meaningful type certificate, and that's what we've entered for the type certificate from our side. There are many different discussions that are ongoing at the moment in terms of could you have this also, or should you include other components in a type certificate, and there's some people that are considering to enter the whole system, including the battery, in the type certificate for the engine. I think there's the different schools of thought on that one at the moment. Fact is that the authorities have accepted the argument of having the engine as a motor, inverter, and controller. What else can I highlight? I think that's interesting. There's a significant amount of system impact that comes onto the motor, of course, because in the end, if you build the engine, it is not completely like a combustion engine that kind of sits by itself in the front. But if you take the approach of saying we want to look at motor and inverter, you need to consider the interplay between the between that part of the overall system, plus then the battery and the fault propagation throughout the system. So that plays quite a significant part in terms of how you then define the interfaces. But we've so far actually been quite positively encouraged in terms of being able to segregate these parts and the different components in the systems and make that work. Our plan is to continue with the certification of this kind of smallest type certificate, the EPU type certificate. We are currently working on plans to extend this and to ensure that we then can offer the full systems as well in a certified way. That's a little bit further off from a timeline point of view. And at the same time, we have set up some additional programs this year to then provide the product type versions both for the urban air mobility engines, kind of focusing on lift motors. And we have a second program that is focused on providing the engines for higher power classes, commuter-sized engines that would be CS23 up to CS23 ELA4. Now those programs are on a longer time frame. We're not going to have the type certificated version of those engines available in the next few years. That'll take a bit longer. But I think especially what we've learned through the process so far in terms of taking the smaller engine, the 7090 sub 100 kilowatt type of engine through the process, I think that's going to be very informative for everything that we're doing there. Yeah, I think that's kind of the high level overview. Any questions from anybody?
I think I suggest let's do the following, that perhaps everybody makes his presentation either with or without slides, and then we have the questions from everybody in the end, like a real panel discussion. So I would suggest, as we started with one of the beginners on the aviation, on the propulsion system side, it would be great if you, Tom, could give us an overview over what you have been involved from the beginning to electric propulsion. You're in aviation. We know us more than 25 years, I think. So now, what has been the development in on the ASTM side? And perhaps you also can explain how the ASTM actually got into this field of aviation certification. What is the role? There are the FAA, the EASA, but what is ASTM doing there around the world?
Thanks, Willi. So to start at the, the macro level, we have the regulatory requirements for which, in developing some of these new technologies, there have been gaps in the regulations because they didn't really envision some of the technology we have today. So the authorities are having to consider what would be appropriate requirements for things like electric motors and a lot of the other systems that are going into some of these aircraft that nobody's really thought about before. And in that, at the same time, there's been an opportunity to convert some of the regulatory requirements from very prescriptive rules, which were based on what was known at the time the rules were written, to more performance-based rules, which then speak specifically to the aspects of things in a more generic way. So, for instance, when we talk about engines, we would normally think about piston and turbine engines when it comes to regulatory requirements. Electric motors are very different in that respect. And by going to performance-based regulations, then you can talk about something more generically like a power plant or a propulsion system, and then allow for the means of compliance to define what sort of testing may need to take place, or analysis to show that whatever that is meets the regulatory requirements. So in the case of Part 23 and CS 23, that process has taken place at the regulatory level to create performance-based regulations. And it's slowly seeping into other areas. So for instance, with Part 33 or CSE, there we still have those very prescriptive requirements, which are based on whether you have a piston engine or a turbine engine. And the regulators have seen that the best path forward in the short term, because rulemaking takes so long, is to come up with special conditions, which would allow an applicant to come to the authority based on what the authority thinks is generally the right direction for those things which aren't covered under the current regulations. So there's been a lot of work on the industry side to help make sure that there are some means of compliance that are generally agreed to. That helps everyone. The authorities would prefer not to have to go through this process individually with every applicant that comes along, especially since there are so many players in this new field. And so there's been quite a bit of work, both with the authorities and the industry together, to try to create some consensus standards where possible to help in assuring that what the authority thinks are reasonable special conditions, meaning the regulatory requirements, there can be some known ways to comply with it. So FAA and EASA take a little different approaches. EASA is much more open in their approach, in that they're coming up with proposed special conditions that are relatively generic in scope, and they're actually there's currently forgot what it's called.
The special condition electric propulsion units.
Yeah, so there's a proposal out right now for comment from EASA. Yep. On their special condition, which they've published, so that the industry can, and anybody else for that matter, can provide some input toward what that would end up looking like, so that, especially for applicants, they know ahead of time pretty much what to expect. FAA takes a little different approach. They like to do it on a case-by-case basis, because they feel that there's so much variety in what applicants are coming with that they really don't feel comfortable with codifying at this point one way to do it. So that's not so visible to the rest of the community, but there are applicants in process who are already working that, as we just heard from Olaf, that are beginning to flesh out what that might look like. So in the background, what's happening is that in particular, FAA and EASA are working very closely together to try to make sure that if there are differences between their approach to what those requirements should look like, they're very small. And that then feeds down to those of us who are working on the standards that could be used to show a means of compliance to those. So for instance, today we have an ASTM standard, F3338, if you wanted to look it up, for electric propulsion means of compliance to what everybody is kind of guessing a little bit will be the special conditions from both FAA and EASA. So it's a little chicken and egg as far as how the process works. But the main thing is that the authorities and industry are working very closely together to try to make sure that there aren't any significant gaps in either the regulation or regulatory language or the means of compliance. And a lot of this is driven by, well, the big issue is that because this is all new, there's not a lot of data to work with to confirm what the best approach is. And so that means that there has to be a little bit of, I guess I'll say, faith in what is being provided to show that an applicant can get through this process. So there's multiple standards groups working on different areas in helping with this, everything from the propulsion system to all the components, all the way through charging of batteries, things like that. And that's ongoing, that will just continue to go. And there's, so I think of some of those groups, RTCA, SAE, ASTM, and there's an JARS, EuroK. All these groups are working toward helping provide this kind of information. And I think I'll leave it at that, Willi, because that probably will create enough questions later.
Yes. So, okay, then now we heard about the regulatory side, we heard about the motor side. So perhaps we would go now, perhaps Konstantin, perhaps you could give us first the applicant side of somebody who builds an aircraft and wants to use an electric aircraft, and where you are on the certification side. I know that at the beginning with Elektra Solar, you started with on the ultralight side, an ultralight aircraft. Please give us an update, share your screen, and then we will have more questions, I'm sure, later.
Okay. So just a second. So can you see the screen?
I see it perfectly.
Okay, good. So first, thank you very much. Yeah, it's a pleasure for me here to make this introduction to our current state. So unfortunately, my colleague, Kalin Gologan, who's supposed to give this presentation is not here. Yeah. So my role in the company Elektra Solar is everything connected to electronics, autopilot. Yeah. So, but today I will give overall presentation, yeah, of where we are at the moment and what are the next plans, yeah, in the sense you introduced. So, just a second. Good. As you know, we started with Elektra One. This was a work of Kalin with this small aircraft, and it is in flight operations since 2011. Yeah, 2015 we had a demonstration flight over the Alps, and now we are working on this aircraft towards different applications. Yeah, so you can see here on the image aircraft, which is equipped with a camera, with a high resolution camera. We can take images and then do the pre-processing on board and transmit the images to the ground or save these high resolution images and reconstruct 3D models of the environments. Yes. So here we are on the next level. So we think that this type of aircrafts are more or less developed to this level of development, and now we are focused here on the developing of applications, yeah, based on this aircraft. So then we have also a larger aircraft, Elektra Two. It's around 30 meters wingspan and also heavier, up to 5,000 kilogram. Here, the main goal is to develop the systems, solar electrical. So here we have an additional component, a solar generator, and to go with this aircraft to the higher altitudes. Yeah, so we are talking about missions at the altitude of up to 20-25 kilometers, and the idea is to stay on this altitude theoretically unlimited time. Yeah, during the days we can recharge the batteries, and during the night we can go a little bit down, yeah, but stay nevertheless at significant altitudes. Yeah, so here we started with aircraft which was provided to the project Solar Stratos. Here, this is on the top of the image. And here's the second image shows the flight at the altitude of 10 kilometers. But in this case, we have unmanned version. Yeah? So actually, we operate these aircrafts, Elektra 1 and Elektra 2, in these combinations with a pilot supported by autopilot in so-called optionally piloted mode, and we also operate this aircraft as a pure UAVs. Yeah? So, and in this second example, we have a pure UAV version of the aircraft, and the flight at the altitude of 10 kilometers. Yeah, here we work in parallel. We have been improving the aircraft, still working on new modifications to make it lighter, to increase the possibility to stay on higher altitudes. And of course, we are looking here also in parallel to the applications, yeah, and applications. Actually, here we are talking about the same applications we have with the satellites. Yeah, so it's also clear that such a solar electric platform is much cheaper. So now we can also talk from our own experience about the costs. Yeah, that using this aircraft, we can provide more or less the same, or I would say up to 90% of the services which have been providing now by the satellites, but we can reduce the cost by 1/4. Yeah? So we are not talking about 2 times, we can say here 10 times cheaper. The better quality of the data, because the distance to the Earth surface is 20 kilometers, yeah, compared to several hundred kilometers in case of satellites. So we have also much better resolution of the sensors. Yeah, and of course we can land this aircraft, perform the maintenance, and then start again. Yeah, exchange the sensor payload. Yeah, it's a really interesting direction here. Yeah, which we follow, and I think it could be. Yeah, like a new revolution in communication techniques, and also in applications connected to some kind of observations. Yeah, so this is our current status with these aircrafts, and I go further to this project, Elektra 10. It's a small aircraft for 10 passengers. This is a cooperation project, or this project belongs to Skylux, but the shares of Skylux are owned by EATCO and Elektra. Also, other companies, one airline, and is part of this project. So here we have a vision to connect some suburban areas with cities and with airports. We don't have now, or we didn't put on the slides additional images with a special takeoff and landing system based on a moving platform. So we would like to be able to start this aircraft from a simple field. So we don't need some installations here, just some preliminary preparations so the aircraft can start to take off and land. Yeah, so good. The weight is around 3,500 kilograms, and what we would like also to introduce to the system is so-called one pilot operation. Yeah, so equipped with a full functional autopilot, yeah, we would like to reduce the cost of operation by having only one pilot in the cockpit. Yeah. So this the project is in the status of so the status of the project is a pre-design is finished. So we are now looking for financing to build a first prototype of this aircraft. And on the last two slides, I would just talk about the certification plans which we have now. So we are in the process, or better to say, we are about to finish certification of Elektra 1 for ultralight German rules. The propulsion system we will certify for ASTM standards, and later, based on this preliminary work, we would like to go for CSLSA, EASA certification for Elektra 2. Yeah, so in the last slide, some more details to the development of the propulsion system. We are talking here about power ranges of up to 50 kilowatt. Yeah. So we started to work with Geiger Engineering, with Joachim Geiger, many years ago, more than 10 years ago. Even the very first aircraft, Elektra 1, was equipped with this engine. And after some time, we decided to go together with him into the development. So now it's a joint project between Geiger Engineering, German Airspace Center, and Elektra Solar. And we have been developing here a special type of engines or propulsion systems which are able to fly also at the very high altitude. Yeah, we have many challenges there. The huge temperature range, we are talking about plus 40 up to minus 90 degrees. Yeah, and of course the highest possible efficiency is requested here. Under propulsion system, we understand motor controller, battery with battery management system, solar converter, and solar generator. So everything together is a propulsion system, and on all the components, yeah, we have been heavily working in the last 2 years, and we hope this year to have the possibility to test the very new version on the altitude of 20 kilometers. Yeah, this is a completely double redundant system. We have 2 motors, 2 sets of batteries, 2 motor controllers, yeah, 2 solar generators and 2 solar converters. So everything is doubled. And the idea is also not only to equip our equipment, our aircrafts with this equipment, but also to sell the propulsion system or components as standalone products. Yeah? So this is a short introduction in what is going on in this area, yeah, in our company.
Okay, thank you very much. I already have some questions, but I keep it until we have heard the last presentation. Uwe, so perhaps you can give us your update on where Airbus is with the electric activities, especially on the point of view with the different activities and on the certification side, especially of the propulsion system. Because we talked about fixed wing aircraft. Now we go to the field of urban air mobility.
Yes, correct. Wait a second, I will share the presentation.
Yes, it's coming. Okay, yeah.
So now I will focus a lot on our CityAirbus Alpha and give a little bit a way ahead what we what we will do next. But first of all, I want to show a little bit the status of what we did in our CityAirbus Alpha activities, since this is a big driver for our next generation aircrafts. This is a big driver for our specifications, requirements, and then in the end also certifications and things or activities. Here you see a little bit of timeline for our current project. So CityAirbus Alpha, it is flown by end of last year for first time. And here you see a lot of things we did, mainly focusing on the electric propulsion system. So we started here in 2017 with development testing of our propulsion system with the propellers. Then there was the dysfunction integration test bench where we had the motors, inverters, batteries in the loop. This test was mainly used for qualification, not for certification. So far, it was mainly used for qualification. And then in 2019, we entered in our ground and flight test phase. This was our propulsion system. This was a cooperation. Olaf, you know it pretty well with you, Siemens, and now Royce. We are still in this, qualification and flight test phase. Maybe to give you a little bit an overview, what is in here in the CityAirbus Alpha, or what was the approach, why we have started the project. It was very concentrating on this multi-copter architecture, and it was meant as a quick proof of concept. In terms of, are we able to control this kind of aircraft? Multi-copter is full size and full weight. And we have concentrated a lot on an architecture, safety architecture of all the systems, which is close to close to a product, I would say, but not from a qualification standpoint, but from a function and architecture standpoint. The rest, I guess, it's relatively known, since it's there are some official videos existing. So this is a multi-copter architecture. We have 8 propellers, so therefore also 8 EPUs. We have a propeller which is turning at relatively low tip speed. So therefore, this is a big challenge for the motors. They need a lot of torque. They are, this is an RPM controlled aircraft, so therefore you have to change the RPM quite often. So therefore, this is a big challenge here for the EPU, for the batteries, for the distribution system. This is here a bigger model of the aircraft. You see there is a cooling system installed on the aircraft. So it was designed for 35-degree atmospheric temperature. There is a distribution system which allows to distribute the energy from 4 batteries to 8 motors, and it can handle a lot of failure scenarios. The inverters and the EPU, so the 8 motors, 8 inverters. This is what we call EPU on our side. Here to give you some milestones and an outlook. So you see here there was a flight last year. We had a couple of flights this year as well. This is quite interesting. So in last year we had, in the summer break, we had a first need for system upgrade, since in the ground test phase and ground run phase we have figured out that we need to upgrade some systems. And this there you see already that we are quite at the beginning of our journey. So it's really a lot of things to do. Since now here it's not only the motor, not the electrical system, it's also a new type of aircraft. And therefore, I guess if we ask ourselves if we are ready for certification, I will answer yes in terms of architecture, capabilities, and functions, since this was already demonstrated, but maybe not in terms of certification rules, safety aspects, and standards, since they are now starting to be established from really top level, aircraft level, and then down to EPU or electrical system level. And I guess on our side, really we focus a lot on the aircraft level first, and then derive all the specification environments afterwards. So therefore, this was a little bit my answer here for ready for certification. Yeah, that's it for my presentation.
So
yeah, thanks.
I have some questions. Perhaps if somebody of the other panelists has some questions, I'll leave you first to ask your questions. Otherwise, I would start with my ones. Okay, then perhaps let me start with a question just following the last presentation of Uwe. When you talk about the certification, you have the motor. Would you think that you would rather certify the aircraft with a propulsion system as a unit, or you would have a certified aircraft and then have different certified propulsion units where you could choose one or the other? Like it is, like, for example, if you have an Airbus, you have the Airbus certification, and then you can use Rolls-Royce turbines or GE turbines or other turbines where the turbine itself is certified, or the same in general aviation. Very often you have a certified airframe and then an engine with a TC. Would this a way, or would you think with the complexity of an electric propulsion system, you would rather have the propulsion system certified with the aircraft?
I guess at the moment it's quite open. So this is a discussion which is also ongoing in Airbus. Since as you said, it's quite, it's very complex, since you have now a big correlation or a big link between EPU, then the choice of your aircraft concept, of your architecture, and then safety aspects. So in my opinion, a lot of components, they are linked to each other, and therefore I guess it's not so easy to answer like on an airplane or on an airliner. So we go through now, this is our current or our actual work. We go through really the entire system, and we figure out what is the interaction between all the systems, and we see quite a big interaction between EPU topology, EPU capability, the propellers, and the choice of the architecture. Therefore, it's a quite challenging question. Sorry, I cannot answer fully to it at the moment, since we are really in a process where we go through it. But maybe Olaf, you can also give your standpoint here. If it's really if we could be able to isolate the aircraft and the EPU, or if it's always a combination.
I mean, I think from my point of view, especially if you look at the complex VTOLs, then there's a much greater degree of interaction between the EPU and the aircraft than I think before. You know, just the level of integration is more complex, because we have a greater amount of interaction between the way that the airframe is set up and where you place certain components and how you connect them. So I think the interplay between the airframe maker and the engine maker becomes more significant. On the other hand, I think with a very good way of describing and simulating the system itself, I think you're then able to really describe the requirements that you need to have for the various system components to quite a good degree. But on the other hand, there's so many specialities involved in all these topics that I think the optimal result you can only really achieve if you work really, really closely together in all the various disciplines.
Yeah, correct. I mean, we have to align really and harmonize our interfaces, which is quite tough on this kind of aircraft, since you don't have one interface. You have a lot of things, and safety aspects also, they are interfering a lot. So therefore, we have to work much more together, I guess, on both sides. Yeah.
There would be one follow-up question on this, because like Olaf, now you said there is even more interaction between the EPU and the aircraft. But you said that at the first place, you're going for a certification of inverter, motor, and not even the battery. So then there is, again, because there is also this very strong interaction between the motor, propulsion system, and the battery. So at this point, I don't think there is any common interface which would define how the battery has to interact with the motor. So would then be like a motor where only the motor is certified be useful for an airframe manufacturer, because then he would have to go very deep into the battery? Or are there companies which are offering just the batteries?
So I think, would it be useful? Absolutely, 100%. So in any certified system, the ICD, interface control documentation is vital. You need to know how to connect the system. You need to know how the system behaves if you have certain connectivities. I think the more important point is that the question is how much flexibility remains for the producers and the manufacturers of other systems. And I think this is the key point. So to take a random example, if you need to have a certain safety aspect, like being able to disconnect a current carrying component, to disconnect a current carrying wire, if you have, as part of the system architecture, defined that this is not inside the scope of the say the motor, the inverter, and controller, then by definition you need to have that somewhere else inside the electrical system, inside the electrical distribution system. So the degrees of freedom for the remainder of the system are then curtailed. You can't just decide anything, and that's I think the important point. If you design and develop something, it will have a certain it'll have certain safety considerations, it'll have certain failure cases, and it'll have an idea in terms of how reliability is considered. And that then has to work inside the remainder of the system. And I think you're able to create quite a good basis, but you're probably not going to have something that then just works in any combination of systems. Having said that, you can't use a gas turbine for an A320 for helicopter. So those are also different systems. So that we're in kind of, it's still in the same domain, but the number of interfaces is there. You need to manage them and you need to describe them.
One question which would be also follow up on this to Tom. Are you aware that ASTM is working in defining this kind of interfaces? Because I think they are vital when you later say you have different aircraft manufacturers, different component manufacturers, if they should work together and not everything has to be defined again. Other initiative for defining this standard, for example, the standard connecting between the inverter and the motor, or the standard connecting between the motor controller and the battery system?
So I think right now that's not a current effort that's going on for any of the specific standards that are in development now. Other than there may be some of those where you get into specific connections. SAE is really good at developing standards for smaller components like that, where they might describe a system and where you'd want to have commonality. But I think that until some of these projects come to fruition and it gets understood what works well, especially when you consider we're dealing with some pretty high power connections, which I don't think is too typical, at least on the smaller scale aircraft. You get into the big ones and they might be already dealing with that. And there may already be some standards that would cover some of that. But in terms of having a one-stop shop where you could find a standard that would cover all of the integration, I'm not sure we're going to see that. The other part is that it just as was just described, if you're going to have a propulsion system that's being integrated into an aircraft, there's already quite a bit of information that talks to that when it comes to how you would comply to regulatory requirements. I think of in ASTM, there are standards that are developed for Part 23 or CS23 aircraft, for which there's already quite a bit of discussion about integration requirements. They're a bit generic though, and I think what you're talking about, Willi, is, can you go somewhere where it says use this kind of connector or
yes,
something like that. I think it's more, make sure it's safe, and you need to prove your case, which is going to be on more of a case-by-case basis.
Right.
As you talked about high voltage, I think high voltage is a key factor, especially when we have things like Konstantin, you mentioned your aircraft you already have been flying up to 10,000 meters. So flying at 10,000 meters, I think it's very difficult to know how this would work with high voltages. How do you cover this? And the same question later to Olaf, because when you want to do later commuter engines, the aircraft and the propulsion system must be capable to work even in 10,000 meters. The air density and everything is very different. So also the electric reactions could be different. Are there already tests being made? So perhaps first Konstantin and then Olaf.
Okay, so short answer to your question, Willi, it's very simple. We don't use high voltage, so this is we use currently 60 volt system on our aircrafts, and the reason is not problem with high altitudes. The reason is just that we are a small company and we would like to organize our work in a very economic way. Yeah, so having a 60 volt, as many of you know, it's very easy to handle. Yeah, in the production process. So, and this is the reason why we stay with this 60 volt technology. Yeah. So, okay, good. This is a short question, short answer to this question. Perhaps a comment to general problem, high voltage and high altitude. So, to be honest, I don't think that it is really issue here. Yeah, you could. So this the phenomena of high altitude, so this change of the atmosphere, for this type of question is understood very well. So I don't see a problem to make a system also with 400 volts, yeah, which will be reliable on a higher altitude. So
yeah,
I would like to give a very short comment also to this point with the certification. Yeah, so if you have to certify a complete electrical propulsion unit or in the components, so actually the certification process is composed naturally of, I would say, separate consideration of each component. Yeah, because a battery system is completely something completely different for a motor controller. Yeah, so and of course. At the end, you have a specification for a complete system, but in the design process, you consider each component separately. Yeah? And to my opinion, the issue is here, or the difficulty is not to define which type of physical connections we should have. The issue, so this is one of the issues, but more complicated issue is here to align the specifications of each components. For example, yeah, if I have a motor from Rolls-Royce, yeah, and the battery system from Siemens, it could be that peak current for a motor of Rolls-Royce system is defined in such a way that it does not really comply with battery system. Yeah, so this internal parameters of each device, they should be aligned with each other, and I see here a difficulty, yeah, because as everybody knows, if you connect yeah, the components together, could be some surprising effects. Yeah, so and how to make a standard that everything is considered in the interface document. It seems to me be one of the challenges here.
okay. Olaf, I still would like to ask you the question, as you were talking in the, especially in the bigger engines, of even much higher than 400 voltage, where you're gonna be going for the large. So and what I understand from talking with different people, there are some things which still have to be evaluated when you're talking about having 2000 volts in about 10,000 meters, that nobody knows exactly how the reaction in this area would be with a different air density.
I mean, I think you're right that there's a lot of development work that's still needed. So we have programs running, developing systems both in the lower voltage range, so sort of 400 to 800 up to, you know, just above 1 kilovolt, and then on the systems for the large airplanes, you know, going up to 3 kilovolts and beyond. A lot of the topics still need engineering work. You know, how do you build out the contactors? How do you work with the isolation? How do you ensure that partial discharges are being handled? How do you ensure a graceful degradation of the system, because you might not be able to avoid it completely? I don't think any of it is unsurmountable. It's some heavy engineering work that needs to be done. We know today that we can fly systems in the kind of 400 ish, 400, 500 volt range, we can fly quite comfortably. And I think sort of in the next few years, we'll see systems that sit at the 1 kilovolt that will be out there and will work. And as Konstantin says, the systems have to work together. So you know, it's no good for me if I've designed the inverter and the motor to work with a DC link of a kilovolt, and then I have a battery that comes and only gives me 400 volts. You know, that's not gonna cut it. So we need to be able to have that flexibility. Fortunately, on the battery side, at least, you know, you're able to size the batteries through, you know, your parallel and serial arrangements quite effectively. So that's a good that's a good design tool that exists in a sense, or design freedom. The complication, of course, then comes on the battery side. Please make sure that this great new arrangement of cells that you've made is now safe, and that I'm not going to have problems when, God forbid, some kind of error occurs. So a lot of tricky engineering work.
Okay, thank you for the answer. And I see from the time-wise, it's nearly like with the normal panel discussions. We always at the end, the time is running short. I know I asked you only for 1 hour, and I think 1 hour is also good for the people to visit. I just have one final question to Uwe, and then I would leave you with your home office or office work, which is quite difficult in those days. Uwe, you mentioned, you talked mainly about the CityAirbus and about all the propulsion systems we work. So we all know that Airbus is working on different projects in this field on the UAM area. So would you, can we expect any other Airbus eVTOL coming soon? Or if and this again, will this be then in the same field, like the same size of aircraft? And would this then be a project which already is going for a product being certifiable with the propulsion system, or would this more be another demonstrator of technology, like you had the Vahana for the winged aircraft, you had just rotor lift aircraft, which is a CityAirbus. Can you give some little light up here?
Wow, this is a huge question. Thanks a lot. We, you know, we are now in our definition phase for what could be a next project, and in terms of size, I guess we are quite there. So what we have seen is that the size of the aircraft is more or less what you need when you want to carry 3 or 4 persons. So I don't speak about ultralight or a one passenger aircraft. I speak really about 3 to 4 persons, and there we see that the size of CityAirbus is quite good and quite representative. So this is what we see in our studies now. Yes, there will be a next aircraft. When we will start, I mean, it depends on a lot of things. And you have to mention we are, you know, we just started with flight testing our Alpha, so we have to really learn more about those aircrafts. We have to go to limits. We have to learn what is a proper specification for all the systems, and therefore you need to gather all the data. So it makes no sense to start now again a project without learning from what we have. But yes, we have a lot of studies running, and hopefully you know, one of them will succeed and will be the successor of our Alpha. Yes.
Okay, thank you very much. So thanks all for joining.
Yeah, thanks.
Special thanks for Tom getting up early for us, because we are sitting all in Europe. He's sitting in California. But and one wish for everybody, yeah, stay healthy, and perhaps we'll have another discussion very soon. Thank you very much.
Thank you, Willi.
Yeah, thank you.
For the organization, Willi.
Bye.
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 Bye.